In this video, you will learn how to verify a trig identity. Verifying a trig identity is very similar to what we were doing with simplifying. The difference is, here you know what your end product is supposed to be. You know what you're trying to get to. A lot of the time, that is the same answer as if you were just to simplify, but not always. A verification of a statement is a logical statement that is a true statement. The trig identities can be used to verify other trig identities. So if we take this first problem in the box, the very first step is you want to decide which side is more simple. Here, the right side is more simple. Once you decide that, you can then simplify the other side. So here, the left. The first thing that we're going to do is use the Pythagorean identity to simplify the numerator. Then, if I change things in terms of sine and cosine, so tangent squared becomes sine squared over cosine squared, and 1 over cosine squared is the same thing as secant squared. I can multiply top and bottom by the reciprocal of 1 over cosine squared, simplify, and everything cancels out to leave me with just sine squared theta, which is what my right side was and I was trying to get to. Let's now try another example. In number 1, it's hard to tell which side is more simplified. When that's the case, I would usually recommend just go ahead and simplify the left side. So when I look at cotangent squared divided by cosecant, I see that that's a fraction, and what I'm trying to get to is not a fraction, and actually it's not even one term, it's 2 terms. Whenever I'm trying to make one term 2 terms, I'm thinking of my Pythagorean identities. That means I want to look at something that might be a squared term that I could make into the other 2 terms that the Pythagorean identity would equal. Here, if I look at the cotangent squared of x in the numerator, I know that by the Pythagorean identity, that's the same thing as cosecant squared of x minus 1. So I can go ahead and replace that. Once I've done that, again, remember you're trying to get 2 terms. Something that you can do is you can separate one fraction into 2 fractions if you have the 2 terms in the numerator. So this would become cosecant squared divided by cosecant minus 1 divided by cosecant. Next, if I simplify some things, I see that 1 cosecant cancels with 1 from the numerator, leaving me just cosecant to the first power x. Then, by the reciprocal identity, 1 over cosecant is the same thing as sine. And since that's what I was trying to get, I know that I'm done. You'll notice here in the verifying that the answer I'm looking for is not the final result, because obviously that was given to you. What I am looking for are the steps that you took to get to that final result. Number 2 is very similar in that you're going to want to use the Pythagorean identity in a different way. You're going to want to take one of these squared terms and change it into the either 1 minus cosine squared or 1 minus sine squared. Look at what the end result is and decide which one you think you want to do. Then go ahead and try to simplify the left side of the problem to 2 cosine squared x minus 1. Pause the video and check your answer when you're done. Here, because I want to have 2 cosine squared x's, I'm going to change the sine squared x into 1 minus cosine squared x. That gives me everything in terms of what I want in the end. Now what you must remember is that this negative does need to be distributed. And so therefore, cosine squared x minus 1 plus cosine squared x. Next, if I combine my like terms, 1 cosine squared x plus 1 cosine squared x is 2 cosine squared x. Then I still have the minus 1. And that's what we were trying to get, so I know I'm done. Let's now move on to number 3. In number 3, again looking at this, both the left and the right look about equally the same. So we're just going to work with the left. Here, what I'm noticing is that I have pretty much the same terms, but I want to end with this denominator in the numerator and a different sign in between the terms. That's telling me that I want to multiply the numerator and denominator by what we call the conjugate. The conjugate is going to be the same two terms, but with the opposite operation. And whatever you do to the denominator, you have to do to the numerator. Now with the numerator, that's going to give me the sine x that was there times the 1 plus cosine x that was my conjugate I multiplied by. In the denominator, I'm going to have to do FOIL to multiply and see what I get once I'm simplified. So 1 times 1 is going to give me a 1. 1 times negative cosine x is a negative cosine x. Cosine x times 1 is a positive cosine x. And cosine times negative cosine is a negative cosine squared. The middle terms cancel out, leave me 1 minus cosine squared. The nice thing about that being 1 minus cosine squared is that now I have a Pythagorean identity. And so I can change that denominator into sine squared x. Next, I notice that I have a sine in the denominator, and in the numerator multiplied is another sign. So I can cancel that sign with 1 from the denominator. That's going to leave me with just the 1 plus cosine x in the numerator and just a sine x to the first power in the denominator, which again was the goal we were trying to get to. So I'm done. Let's now look at number 4. And what I'm noticing in number 4 is that on the left side, I have 2 different terms to the 4th power. And then on the right side, I have the same term but twice to the 2nd power. That tells me that the right side is more simple, and again, we want to work with the left. Now again, what I'm noticing is I want to end up with just 2 of the cosecant squared terms. So somehow I need to change these cotangent to the 4th powers into just cosecant. If you look at your Pythagorean identities, cotangent squared x is the same thing as cosecant squared x minus 1. So if I separate the cotangent to the 4th power into 2 separate cotangent to the 2nd power, these are the same thing, it's just not multiplied. This allows me to replace each of these with the Pythagorean identity. Unlike some of the other identities, the Pythagorean ones have to be squared. So I couldn't simply just say, oh, cotangent to the 4th x is the same thing as cosecant to the 4th x minus 1. You do have to have them squared. And so now I'm looking at, I need to, again, FOIL these terms out so that I can simplify them. So if we do that, I'm going to have cosecant squared times cosecant squared which is cosecant to the fourth. Cosecant times a -1. -1 times cosecant squared is another negative cosecant squared. And -1 times -1 is a +1. Simplifying, that leaves me with the cosecant to the fourth, -2 cosecant squared x plus 1. If I now distribute my negative sign, that's going to give me a negative cosecant to the fourth x plus 2 cosecant squared x minus 1. And now I notice that I have a positive cosecant to the fourth and a negative cosecant to the fourth, which cancel out, leaving me 2 cosecant squared x minus 1, which is again what we wanted. Why don't you now take a look at number 5. When you're done, compare it to the video. In this problem, I'm noticing that tangent and cotangent are reciprocals. And so if you change either one of them to the reciprocal identity, again, when I multiply straight across, I am going to get something divided by itself. And anything divided by itself is a value of 1, which is what we are trying to get. Now take a look at number 6. What you're going to notice here is that the right side is more simple than the left. I'm also noticing that somehow I need to make 2 terms 1 term. And so probably the easiest thing to do here is to just do the simplifying that you were doing before. Please pause the video and complete number 6. Compare with the video when you're done. If I go through my steps, I do not have any cofunction or negative angles. Nothing is squared, so I can't do a Pythagorean identity. I right now don't have any fractions to combine. I don't have any common terms to factor out, so the only thing you can do is change every term into terms of sine and cosine. Cosine is obviously already in those terms, so is sine. But tangent, I can use the quotient identity and change that to the sine of x over cosine of x. If I then multiply those together, that would give me sine squared x over cosine of x. If I go back through my list, I notice that I do have 2 terms, one being a fraction. So I want to get a common denominator so that I can have just 1 term and 1 fraction. That means I need to get each denominator to be cosine of x. So if I multiply top and bottom by cosine x, I actually get cosine squared over just cosine, plus the original sine squared over cosine that was there. And now because I have a common denominator, I can add the numerators. What I'm now going to notice is that I have a Pythagorean identity in the numerator. And so if I do the Pythagorean identity, making that a value of 1, it happens that 1 over cosine is the same thing as secant by my reciprocal identity. And since secant is what I was trying to get, I am now done. Please now complete your worksheet, which is homework for tonight.